Hi everyone, welcome to our webinar today. So today we will be talking about how we can improve Splunk's performance by performing some health checks, and we'll talk about differences between what's already available on Splunk and what we as an organization can offer in the form of health checks. So the agenda for today is we'll touch upon the common health issues in Splunk and how they impact the day-to-day businesses. Then, secondly, we'll talk about the current Splunk health check that is available out of the box with inside of the Splunk console and the problems with it, and how our tailored health checks can help customers. We'll talk about some case studies as well, and then we'll talk about some remediation actions and how we can help you with the remediation actions. And then we'll close it with some Q&A. So I'm Murugan. I will be your co-speaker. I have over 10 years of experience with Splunk in particular. I have done a lot of Splunk enterprise and Splunk enterprise security implementations over the course of my career, and I've worked across different sectors and yeah, different major organizations. Sheetal Prasad, who will be our main speaker, he is our Splunk expert. So he has a lot of implementation experience and he specializes in the premium solutions such as ITSI and Splunk Enterprise Security. So he will walk us through our content today and then he will talk us through some interesting case studies. So, with that introduction, I would now hand it over to our main speaker, Mr. Sheetal Prasad, who will take us through our content. Sheetal, over to you. Thank you.
Thank you so much, Murugan, for the introduction. Hi, everyone. As you already know, my name is Sheetal Prasad. Let me turn on my video. As we have mentioned before, as mentioned in the agenda, now we are going to discuss in this presentation the very critical and common challenges that we see in our day-to-day life. So I have worked with multiple customer with multiple across globe, across domain. So as a Splunk engineer or Splunk expert or implementation engineer, it's very critical to have a very stable environment. It's not just about implementing Splunk and leave it there, right? So today we'll discuss something critical for anyone who is managing a Splunk environment, right? So as I was speaking from my past experience, what we have come across as a problem in Splunk when so one is data quality, right? So as you can see, I have shown here under data quality, we have received a lot of complaints from customer that the timestamp parsing is getting failed, and there are various reasons for timestamps to not to pass correctly. And I'm not sure if it doesn't sound very important, but it is actually very important. The timestamp passing is very important in Splunk. I'll give you an example. So if we do not have the proper timestamp in place in the configuration, our passing configuration, the events might land in the future, events might occur in the past, or it can be on the real time if the passing is correct, right? So basically, we will not get the insight what happened or what is going to happen. Example from a security perspective, if a brute force attack already happened and our SOC is completely blind because the event has not been arrived yet, it will land in the future. The damage is already done, right? So data quality in particular timestamp passing is very important. It's not only a technical issue, we have business impact also. So one brute force attack or any phishing or any kind of attack is very, very impactful to the business and the credibility with our customers. So also it can also contribute to delay in indexing, right? As I spoke earlier, it might land in the future. So we have seen multiple scenario occurrence where the time, so the Splunk implementation engineer will implement everything and they will go away. There will be new data source coming in. And based on the data, so the data source actually, it varies from security. So we don't know, security events are different from transaction events, right? So the time stamp passing configuration should also be different. So we have example, we have a set of configuration for timestamp passing. We have prefix that we use. We also have timestamp look ahead. So related to this, we have many configuration, and based on the events, we need to have those proper configuration into the place to have a complete insight of our data, right? So moving on, under data quality, we also have one more issue, which is line breaking issues. So it might not sound a very big issue, right? But it is actually. So based on event to event, we might have different kind of long events, XML event, JSON event, and those events typically are very long and it has a lot of information, right? So, so we have a set of configuration in Splunk in order to avoid the truncating. If the events get truncated, meaning it will shrink the data. And as you can see, you will see something like here, truncating line because of limit 10,000 bytes has been exceeded. So what will happen? Our first set of data, which is not truncated, will be there, but the rest of the data and the field values will be missing. So it will impact on the insights. It will also contribute on the reports, right? We might have created few SPL based on the data which are truncated now. And because of the fields and field values unavailability, those reports will not be generated because there are no data. So this is also a very, very important things to be taken care of. And so these are some business impact. So data loss, miss alerts, inconsistent reporting that I spoke earlier. So reporting, we will not get the complete set of reports, what we need, what we require, what our business require for the monitoring. And based on if the events data is not present there, we will not have our alerts. So we might miss our valuable alerts as well. So these are all about the data quality that we generally see in our day-to-day life. This is very common issue, and as it might not sound important, but it is actually very, very important. Right. So following up, we have data ingestion delay due to passing. As I spoke earlier, right, here data quality line breaking failures and timestamp passing failures. So these are actually contributing here in Splunk. The indexing journey has 4 pipelines. So it is a journey from the forwarder to the indexer where the data gets stored, right? So these 4 pipelines are very important and it goes in this order. So when we do not have our timestamp passing in proper way, we do not have proper configuration, right? So the queue might get filled up. We'll have queue congestion here. It will say 100%, right? once it says 100%, since it's a pipeline, so logically speaking, if the pipeline is blocked here, there won't be any data moving forward to the next pipeline. So we have complete delay. So unless we fix this issue here, the data won't be coming in time. There will be delay, right? So it is also a missed alerts, misreporting. We are missing out the insights, right? So it stopped data from being processed. It caused delays. It caused missing incorrect events, and and also it slows down the system. That I will speak in our next slide. How does it do? How does it contribute on the effectiveness of our system performance? So those configuration contribute in this passing. Similarly, we have merging pipeline where our line merging happens and time extraction as well. Under typing pipeline, we have regex replacement. So if we have any regex activity, filtering, routing, or masking, uh, all the operation happens here. And lastly, we have the indexing, which is nothing but writing the data into the disk in what manner, if it is a syslog out or TCP out or indexer. So moving on, we have we
Who
also
is
have, yeah.
who is
Is there a question from anyone?
Yes, Sital, before we
Yeah,
move forward, we have a few questions in our chat
sure,
box. Would you
sure.
like to take those?
Yes, yes,
The
sure,
very
definitely.
first is from the timestamp parsing failure. So, what are
Hmm.
the main reasons for timestamp parsing failure? It's from
Great
the Mr.
question. Great question. Great question. I thought people might not be interested in this because it doesn't sound very important, but I'm very happy that it is getting pointed out. Yeah. So for time passing failure, generally what I have seen from my previous experience, basically our passing configuration, we have set up rules, time format, max time, some look ahead, and time prefix. And if there is a inconsistent or if it is wrong, then we will experience timestamp passing failure. Hope that answered the question. We have other possibilities as well, but generally
Mm,
these are the reason which
mm.
contribute to timestamp passing failures.
Yeah. So Splunk
Some
has some
default.
default configurations using which it will try to extract time from the raw data. Now, when these default configurations become inapplicable, then you will have these issues. So Splunk already knows the different types of formats. So there is a special file where all the different formats, the regular expressions for the formats are stored. So Splunk uses that to extract the time, but there is also a parameter called max timestamp look ahead, and the default value for that parameter is 128. So it looks at 128 characters into an event to figure out if there is a timestamp. If there is a timestamp beyond that character limit, that timestamp will not be extracted by Splunk. And in such cases, Splunk by default would use the current indexing time as a time for that event. So say for example, if the event, the timestamp on the actual timestamp on the event is 3 p.m., but the event for some reason arrived at 3:30 p.m., then the time for the event, in case the time is not extracted correctly, then the time for the event would be set as 3:30 p.m., which is incorrect. Which is why Sheetal has been stressing upon the timestamp extraction configuration. So setting the timestamp extraction configuration according to your data sources is very, very important to ensure that all your searches, reports, and alerts produce the right results.
Thank you so much, Murugan, for the explanation. It was very detailed, yes. So yeah, that is what I was trying to explain. Yeah. So so I'm just going through the chat. We have one more question regarding the line break, right? So I think people might want want to know why this line breaker happens from our previous slide. So, like we have explained for timestamp extraction, we also have set of configuration in our parsing stage. So basically, there are line breaker, right, and should line merge settings in our parsing configuration. So what happens if the event is too long or if it is too short, and in should line merge, if we said yes, right? So what it will do, it will from multiple events, it will merge it to one event, which is not correct, right? We don't want to be as one event. So the timestamp will also have, there will be only one timestamp. So it will group together and it will have only one timestamp. So we'll have this issue if we don't do the correct parsing configuration based on our data source. And also there are a few other configuration. I don't want to go into the detail, but there are like new line where it should be the new line and the limitation of the truncating limitation. So by default it's 10,000, but if your event is beyond that character, 10,000 character, you can use that set of character numbers and you replace it here to mitigate this issue. Right. Any more question, Vikas? If I have missed anything?
Yes, we have one from Mr. Manish Singh.
Yeah.
Uh, a, a
A
misconfiguration.
misconfiguration
Yeah.
between server time and index time in Splunk can cause significant issue in data analysis, search accuracy, and alerting. Yes, yes, Managing your actual, yes. Yes, that is what I was trying to explain. So misconfiguration between server time and index time. Okay, okay. So yeah, so you mean the server time in the Splunk and the index time. Yes, it can also cause a significant issues in data analysis. You're right. Okay. So okay, we are in the indexing delay. Okay. So we have covered the passing queue, passing congestion delay, and there are also possibilities the data can be delayed due to regex activity. So we have something called typing queue, right? And there we have the regex replacement. So what happens if we have uh, any so if you want to route the data to different servers, or if you want to filter the data and drop the unwanted data, say for example, if we don't want success related logs because it might not contribute to our insights, event insights, and we only want the error kind of logs, so we can write our own regex to have index only error related logs to our Splunk indexer, and we will drop everything. So it will go to the null queue. So we will drop everything success related data, or except error, we will drop everything and it will not get indexed. So in order to do that, we need to write regex. And in Splunk, regex can be so it also contributed a lot, I would say, because an inefficient regex can slow down your whole system. So regex uh, is very expensive if it is inefficient. It takes so regex basically takes the CPU and memory. It uses the CPU and memory. It track down the character what we have mentioned in our regex, and based on our configuration or based on our regex it operate, right? So if we have a regex, inefficient regex, it might take more time than expected. It might use more CPU and memory than expected, and it might block the typing pipeline. And if our typing pipeline is blocked, same thing will happen again. The data will not move through move towards to the indexing pipeline, and it will cause delay, a data ingestion delay. Okay, so yeah, so we also have data ingestion disruption. So what happens? We have created regex, or we have parsing pipeline congestion. Data is not going moving forward from universal. So these are the universal forwarder, and here in this section we have our indexer. So universal forwarder is trying to push the data to the indexer. We have all set up pipeline here, which is not visible. I mean, which is not have been called out here, but there are pipelines, and it's going through the pipelines, and it is going to the indexer. If we have the parsing congestion here, the data will stop moving forward. It will, after a few time, it will stop reading the data from the universal forwarder. And so when we have parsing queue congestion or any pipeline congestion, it will try to connect to the indexer. It will keep on trying, and once it's failed, it will lose the connection. In order to establish the connection again, we might need to restart the universal forwarder, right? So this also contribute to the data ingestion disruption. So it's very important that we analyze or we identify if we have any issues in our data pipeline, because it can contribute and it can be a very significant issue that will so it is not about the issue occurrence, it is also about identification. So identifying the issue and fixing or addressing the issue will be very difficult, and it will take a longer period of time than expected if we don't do the measures that is required, right? And following on, we have search performance and skip searches. So as we spoke about the indexing issue, similar how the data ingestion can be a problem, can contribute a large extent of issue. Search performance also contribute to overall Splunk health, environment, Splunk environment health. So what happens? So broadly, from my experience, what I have faced with multiple customer, very two common problem we see. One is max concurrent job limit, and the another one is a max concurrent search limit. So makes concurrent job limit. What happens? Say for example, we have more than expected scheduled jobs, scheduled SPL, right? What is defined in the limits configuration. So in Splunk, if we have, so basically we, for everything we have limits in Splunk. We change according to our need or based on the use cases. So if we have makes concurrent job limits 10, and we have scheduled 12 or 15 jobs, search job. So scheduling will create a searching job, right? So if 10, if I have max concurrent job limit 10 and I have scheduled 15, my 10 jobs are running now. So those remaining 5 will be skipped, because my all of my limit has been exceeded. So it is doing its best because we have set the limit, right? So those remaining 5 will be skipped, and we will not. So if the searches are skipped, we missed out alerts, potential alerts. We missed out, definitely we missed out reports, right? And also, it's very important to have the time range, which is called frequency. How frequent the scheduled job should run? Is it every 10 minutes, 15 minutes, 1 hour, 2 hour? So depending on our use case, depending on our data source, we need to have the proper time range and the frequency, the cron scheduled job, right? So what happens if we have short frequency? I have mentioned here short frequency in the second line. What happens? So if you have a non-transactional events, which is not very important, but uh, past maybe Splunk engineer or any analyst has made the cron job to run every 15 minutes. So the job is running, and once the job is running, it will consuming the CPU, it is consuming the memory, right? So it is eating up my CPU and memory. So it will be expensive, and it will cause me the downtime of UI experience. If my system CPU and memory are being used, or it is getting used, or it is exceeding the limits that we have configured, or the based on the course, right? So it's not like we shouldn't do short frequency. It is just that we need to assess all the SPL schedule SPLs, and we need to understand, and we need to have our use case, and based on our use case understanding, we need to configure it in a very efficient way. So inefficient short frequency will cause skip searches as well. So in order to mitigate everything, we need to assess the SPL, scheduling, job searches, and the time range. So this is about the max concurrent job limit. So what about the max concurrent search limit? So based on the job limit, we also have search limit, right? And I have called it out one screenshot that I have taken. So you can see there is a log called the maximum number of concurrent historical schedule searches on this instance has been reached, and the count is 778, and the percent of total is 100%. Once it is going beyond what we have configured, the limit, exceeding the limit, it will have delays in reporting. We will definitely have miss alerts. Any potential alerts will go missed. We will have gaps in our summary data because it is taking longer than expected, and it will skip the searches. So it will not contribute in the summary indexing. So in order to mitigate this, we need to identify our all of our search limit, and we need to fine tune our scheduling of the search. We need to we have few parameters that I have called out here. Make searches per CPU. So we need to understand based on our environment and based on our use case. We need to understand and make those changes accordingly in order to address this issue, right? So following on, we have resource exhaustion. So I talked about two layer. I talked about Splunk's two layer, very important, indexing and searching. And if we have inefficient indexing configuration or search configuration, either of it, it will have impact on our resource for sure. As I have mentioned previously, if we have more searches which is not under our limit, which is exceeding our limit, it will take more CPU and memory. So we will experience for sure high CPU uses. And it's not only about the technical impact, technical side of it, right? It has the business side of it. We will lose, we will have the very slowness of our UI experience. Or if we are in cluster, right? So there will be instability in cluster. If we have any reports configured, if we have dashboard, maybe classic dashboard or dashboard, any of it, we have multiple drill downs, we have multiple SPL invoked into it. And if you don't have if you are not maintaining the standard practice of having the base search using the tokens, it will take more time, it will take more CPU, it will take more memory in order to complete those search job, and it will slow down the entire system. So we will feel, and we can feel the slowness, and it might crash also. I have seen a few instances where it crash the entire system. Giving you a very good example, so it happens mostly in when we have enterprise security installed in our Splunk environment, because we have a various number of data models there, right? And data models should run. It will have multiple lookups. It will have multiple searches to be run, right? So if we don't do the best practice as per the Splunk best practice, and if we so it's not only about the Splunk best practice. We also need to make changes according to our environment, Splunk environment, and our use cases. It's very important. So mainly in I have seen in enterprise, it's not only enterprise security, but majorly I have seen this issue is enterprise security, where we experience high CPU users and high memory users, right? And yeah, so high memory users, so we will have crash like I spoke just now. We will have latency, we will have skip searches and missing alerts. So these are the impacts we will have if we do not do the exercise of assessing our configuration, our environment, and make those changes, right? Uh, we have few chats here.
Yes, Siddharth, we have a few questions in the chat box.
What are the common cause of data ingestion disruption in Splunk? Yeah, so the common causes, where it is, yeah, the common causes of data ingestion disruption is, like I said, inconsistent or improper configuration in, let it be passing, typing, or merging queue, right? Or no, it is also very common, but if we have connection issue from the sender to the receiver, right? So from universal forwarder to indexer, if we have connection issues, we will also experience the data ingestion disruption. As long as there is no congestion in any of the pipeline, or any of the and our timestamp is getting properly extracted, it will go into the indexing, and we will not have data ingestion disruption. So main causes are the improper configuration and connection timeout or connection error from the sender to receiver, basically from the forwarders, let it be UF or HF, universal forwarder or heavy forwarder, to indexer. We have one more question from Manish Singh. Is summary indexing a better for searches that are huge in terms of data?
Sheetal, I
Yeah,
think I'll take this one, Sheetal.
yeah,
Thank you.
yeah.
So, Manish, it comes down to your use case. So, say for example, you have a huge data set and you're only interested in running a report for a subset of that data. Then you go for summary indexing, right? So, if you have logs with success, failures, and errors, and if you're only concerned about a report on errors, then summary indexing is a good option there, whereby you can have another summary indexing search that takes out only the error events and forward it to a different index, and then you build your reporting on top of that index. That way, your reporting will be quicker. If you have a dashboard, the dashboard would load quicker. Um, but if you're thinking that you have a huge data set, and if and you want to run reports on the entire data set, but you want it to happen in a quick manner, then the solution to that is acceleration. So you map the data under a data model and you data model acceleration, and then you use the accelerated data to power your reports and dashboards. Okay. So move on to the next question. What causes resource exhaustion in Splunk? Uh, so Splunk uses resources for indexing and searching. So when it comes to indexing, the resource utilization would be on the higher side if you have incorrect parsing configuration. So basically, if the CPU spends a lot of time trying to figure out the timestamps from the data, trying to figure out the line breakings from the data. So if you have inefficient configurations for these settings for line breaking and timestamp extractions, you're going to see significant CPU utilization in while indexing. And also the disk is also very, very important. If the disk is not capable of writing at the speed, at which the data is coming in, you will see a lot of IO weight, and that will translate into CPU utilization there. So these three parameters, right? So your basically, I mean, I would say two. Parsing configurations is one, and then your disk. If these two are inefficient, then you're very sure to see resource utilization in above normal while indexing. And then when it comes to searching, every search is going to utilize a CPU. If your search is a long running search, then it's going to hold that CPU until the time the search is able to complete. So that increases your utilization. So utilization is always a wait time until which the CPU is being held for the process to complete. So the longer it takes for the process to complete, the higher will be the utilization. Yeah, I hope that answers the question.
Thank you so much, Murugan. Yeah, I think from my perspective, it does answer the question, but yeah, we'll see if we have any follow-up question from Manish or Wang. Thank you. So taking over, let's go to the next slide. Health check in Splunk. So we have talked about the issues. What are the issues might cause you downtime, cause you significant miss alerts, missing reports, and resource exhaustion, right? What about, so we talked about problem and solution, what are the problems and how can we solve? But the very important step is identification, where the health check comes into the place, right? So generally, what is Splunk Health Check? So what it will do, so we have Splunk Health Check out of the box. When we install under monitoring console, we will have Splunk Health Check. We can run health check, get the reports, and we see very few information, or I would say minimum insights on what is happening, if it is if everything is okay or not. We'll get a report basically. So what it does, it will assess your whole Splunk environment. It will perform few checks and it will provide you the insights. So what is the Splunk health check benefits? So the first is identification. If you don't know the problem, how would you go and solve it, right? So it is very important for the identification to be happen, right? If you go to a doctor, he will not go ahead and give you, if you have fever, he will give you some paracetamol or something like that, right? He needs to do the complete health check. He will put thermometer under your tongue and he will measure the temperature, and based on your temperature he will give you recommendation. He will give you some diet plan, or he to fix the, I mean, to make you feel better, he will prescribe you some drug, right? So basically, identification is very important. In order to identify the underlying issue, we use Splunk health checks, and we get out of the box when we install Splunk, right? So, but here is a but. We have out of the box Splunk health check. But what happens, I have seen in multiple, I have experienced multiple occasions. It doesn't give you the complete insight what went wrong, or it does not make you understand, or it does not explain you why this is an issue. What is this issue? It doesn't give you the recommendation how to fix this. And it has some limited checks also, right? It doesn't give you the complete assessment checks. It has limited data integrity and it has the minimal system monitoring. That's what I feel, and that is what it is from out of the box Splunk health check, right? So I have seen gaps. So these are the gaps I have seen from out of the box Splunk health check. So it does the minimum of minimum system health check. It does not give you the in-depth, like I said, it does not explain you much about the issue, and it does not give you the recommendation also, much recommendation, right? Based on your environment, you will have your customization in place, right? So it will not go into those detail and check those. So that's why it's out of the box. It cannot be customized. So this is the gap we see in every Splunk environment. So in order to address this, what we need to do, we need to have tailored health check, meaning based on your environment, we need to have the Splunk health check, right? So I'll make it pop out. So yeah, so basically Splunk tailored health check, meaning we can customize what checks we're going to perform. We can go as comprehensive as we need to be. Right. I'll give you one example. It does not. So if you go, even after this session, if you go and try Splunk Health, it will not give you the details about SSH. If you're able to SSH to those servers where you have installed Splunk, it does not give you the THP information. It does not give you the if you're able to RDP. It does not give you all of your Splunk D logs, errors, and all of those details, right? So it's very important to have the comprehensive insights about your environment. You might do the health check in Splunk, but you'll fail to get, so there will be underlying issues, and you will never know, because it is not designed to customize based on your environment, right? So here we see a very big problem. So in order to have your Splunk health check assessment, we need to go as detailed as possible. We need to have all the checks in place. So as Positka, we do a very detailed, comprehensive health check that includes, as I said, SSH, RDP connection, your security, your network related, configuration. So already existing apps and add-on installed apps and add-ons. If it is compatible to this current version of 9.1.2 or 9.2.3, whatever your current Splunk version is, uh, are you ready for the migration? So we do a very detailed, comprehensive health check, right? So this is a problem that we see in Splunk health check, which comes out of the box, right? Okay, so ladies and gentlemen, let's do a poll. So I would be very much interested to know how often does your team perform a health check in Splunk, right? So is it weekly, is it monthly, is it quarterly, or it's rarely, or you never do because it's not needed, or you do not, think it's very important. Okay. We have very interesting answers so far. We'll give a couple of seconds more. Very, very interesting answers.
Yes,
Oh,
Ital, we can
okay.
conclude the poll now.
Okay, great, great. We have 10 responses. So we 40% are saying they do weekly, which is great. Very happy to hear that. 20% is quarterly, and oh my God, 40% is rarely or never. Okay. Okay, so we see a problem here. Okay, so okay, great, great. Thanks for participating and giving your inputs. Thank you so much. Okay, moving on, let's go to our case studies. So we, as Positka, we have done a multiple, comprehensive health check. We have identified multiple issues, underlying issues, which was not identified by out of the box Splunk. We help customer bring back their Splunk health to have maximum impact. So from not so healthy, from having fever to be completely normal, to be completely healthy. Right. So I would like to share two case studies that we have done very recently. Okay, so case studies one. So one of our customer is from a very large e-commerce. They operate a very large e-commerce, and so they reach out to us having complaint regarding search performance. So as you can understand, in large e-commerce, we have a lot of transactional events, a lot of transactional data coming to Splunk, right? So, someone purchased something, someone added to the cart but never bought that product, right? So they are so in order to do a strategic plan, they need to have all of this information to be in place. So they have a huge collection of reports and dashboard to analyze this, to analyze their transaction data. So we have done the comprehensive health check. We identified the bottleneck in few of the pipeline. We gave the full report, all recommendation what's to be done, and we helped them fix those issues. So yeah, and after fixing those issues, they experience and they witness a very significant improvement in their search performance and operational efficiency, right? And moving on to the next case studies. One of our financial institution customer, were having issues with data growth. So their volume was going exceeded, right? So what we did their index configuration. We analyzed their index configuration, data retention mostly. We analyzed their data growth and file monitoring, and based on those reports, we recommended customer how to fix those issues, and we from our side help customers fix those issues. and they witness a very significant improvement in search performance and data storage, right? So now remediation and beyond. So these were all the issues. So if you're experiencing this issue, what can we do to remediate this issue? So I would like Murugan to take over from here and share and give the inputs. Thank you so
Thank
much.
you, Sheetal. So just wanted to, I mean, in the interest of time, I just wanted to quickly cover some remediations about, all the solutions that we offer. Right. So as Sheetal covered, we offer a very robust health check. So a very detailed health check. It's not a regular health check. So what we can do for you is come into your environment, do a detailed health check, tell you what is working and what is not working, and then give you recommendations for what is not working. And we can do that for free, right? We do that. We do the health check for free, and then we can also help you with the remediations. So we can also help you with administration. We can help you with training. We can help you with, say, for example, if you want to onboard some new data, we can help you with data onboarding as well. We can help you with parsing configurations. We can help you with fine tuning your search and your indexing as well. So we also have a support help desk. And we treat all our customers with high priority. So if you have an issue, if you even if it's just a health check that you need to do, we will treat it with priority if you reach out through the health support help desk. So yeah, so that's what we offer. So Q&A, and what we have covered. If there's any questions, so please put it in the chat. So I see one question: how frequently do you recommend conducting health check for critical aspects like data flow, Splunk, forwarder connections, etc.? So I would say once every month would be sufficient. Anything uh, lesser than that, or anything more frequent than that would be an overkill. So once in a month, and as and when you or as and when you onboard any new data, so it's good to do some health checks to see if everything is good in the environment. So what happens? So the second question is, what happens when Splunk fails to parse timestamp correctly? So when there is timestamp extraction failure, you will miss events. So the events will go haywire. It'll either go into the past or it'll go into the future. It'll have incorrect timestamps. Your reporting will be incorrect. What can I do to get a free health check? So yeah, we'll cover that in the upcoming slide. So basically, we will list on some email addresses, so you can reach out to those email addresses, and they will help you set up an engagement with us, and we can get started with health check. So basically, we'll go through the process of collecting information from you, and then probably over a screen sharing session, we can engage and perform the health checks for you. Right. So right. So we today we covered about the health checks. We covered about the remediation. So what's next? So we will share the webinar recording presentation materials with you after this call. I mean after this session. And then you can reach out to these email addresses that are listed down below, susan@positka.com and or Emilia Fernandez at positka.com. You can reach out to either of these email addresses, and we will get in touch with you to begin the engagement.
All right
All right
then.
then. Thank you very much for joining today. I think we'll conclude our webinar here. Thank you very much.